Hello, I'd like to take a few minutes to go over some mesh optimization techniques that you can use to um, reduce the CPU time and sort of computational load for a simulation by just making some changes to the mesh size and using essentially transparent slabs to block out areas of the gas domain, of the computational domain, that you don't need to compute. You don't need to spend any time computing that, so you can block those out. So when we're starting with, we've got this kind of an unusually shaped model here where, we've got to fit this shape within a rectangular or rectilinear mesh, right? So, we could break this up into smaller meshes, but regardless, you're going to end up with, some amount of space outside of this volume. We only want to compute what's going on inside of this volume of the building and not everything everywhere. And you can see here that this mesh is not very efficient. I'm starting out with like 272,000 cells, but it extends way much past the edges, the top and the bottom of this domain. So the first step is just to, make your mesh, minimize your mesh down to conform to the shape itself. So I often will go into 2D view for this. It's a little bit easier. And then pick the mesh that you want to edit, and then just start dragging and use the bounds, use the farthest point geometry or just slightly past it. To move the edges around to this point. So in this case, this geometry kind of extends into the cell. I could snap it here, but I probably end up cutting something off. So I'm just going to go, the next cell width past this point here. We'll bring this down to kind of the equivalent cell. You'll notice that in PyroSim, when you're moving mesh faces, that they end up sort of snapping. They end up snapping to cell edges. So there's no way to kind of get that off. We'll do the same thing down here and then over here. And we're just grabbing edges, dragging them, and dropping them close. So we've got the perimeter pretty well mapped. Let's take a look from the front view now. And yeah, the bottom is quite a ways off, so we'll just snap that up here. And then if we look here, yeah, we can't really snap to the top. So if we want to close this building or close this volume off, we probably need a slab at the top of this to close that off. So I'm not going to mess with that right now, but just kind of keep that in mind, that it'll be open. There'll be a small crack. Now, technically, if we preview blocks, yeah, it does snap up. So the next, here you can see one cell width. So it does snap up to conform. So it actually closes itself off automatically when we preview the blocks. And if we take a look at that again from the top view, and I preview blocks, you can see PyroSim decomposes that shape against the mesh and gives you the sort of all the obstructions you would need to represent that object. Now, we've brought the mesh in as close as we can, but you see there's still a lot of volume outside of the perimeter of this box that FDS would spend time computing. It's all gas cells. If we go back to 3D view, you can see that a little more clearly here. So we have all these gas cells out here, and it's a significant amount, right? I mean, it's the whole height plus this distance, it's this triangle volume, prism volume that would be computed, all of those cells in there. So what we can do now is we can use obstructions, these slabs essentially in PyroSim lingo. Let's go back to 2D top view and we'll zoom in here a bit. And let's just start over here. So this will be a good example. So grab the slab tool, and in polygonal slab mode, what I tend to do is just start on an edge and click, wherever I know that I'll get to a point here, and then I can just click on that edge, and then this edge, and then close the slab. So now you could continue this around and just do the whole thing as one big shape, but I'm going to do this in a few different shapes just to make it easier to demonstrate. So now that I have this slab, what you can do is make sure that it's pulled all the way to the bottom of the domain, and then mouse over the top of the object and bring it up to whatever the top is. And in this case, I'm going to snap to the mesh corner over here so that it goes all the way from top to bottom. And so now we have a big solid object right here that is effectively everything inside of it is within a solid and is not considered during the FDS calculation. Now, I don't want to see this big block. Maybe I want to see the exterior walls. of this object. So what you can do then is just come into this. What I tend to do is actually I'll make a new group for like something like blanking OBST, something like that, just to give myself, okay, these are all the things that are just blanking things out, and drag and move those obstructions into there. So as I create those obstructions, just put them in a group where they're all blanking. Let's go ahead and do one more just so I can kind of show you another technique here. So we'll go 2D view again, top view. And in this case, we're going to start here and kind of come back around to this point. So let's get another slab going. I'm going to start here, click to here, go all the way down to the corner point. Let's see. Yeah, I'll just stop here. So we'll go to here, come over to this point, and then track all the way back to our starting point, which was there. And now we have another little slab. Let's do the same thing in 3D view. Just pull this up. Edit that, Control Z, bring that up and fill in that whole edge too. So now I have two of those. Let's go ahead and move this one into this group as well. One thing that you can do while you're drawing all your blanking is you can change the group here to the blanking group. And then as you draw new obstructions, they will automatically show up in your blanking group. So it's a little tip. All right. So we can continue around the perimeter. I'm not going to do that now. I'm just going to show you what we can do now with these two. So if at the group level, if we right click and go to properties for the group, we can modify all of the colors and everything for all of the objects at the same time. So what I'll do here is just kind of pull this down. I like to make it kind of a blue color, something, or a color that's a little bit unusual, and then bring the alpha value all the way down to 0. Okay, and now say okay to this, and you can see that they've effectively disappeared. Now, they're not showing up. They'll be fully transparent in the results as well, but they are present. These are still obstructions to flow that block out all of those cells. So even though it says I have 129,000 grid cells, if you subtract from that number all of the cells that I've just filled up with these obstructions, that's the effective cell count of the calculation. And so we've just cut a bunch of CPU time out of this calculation. And that's a big side over here. This will definitely cut a lot out as well. So you could try to compute, you could figure out the length and the width and the day, and try to figure out how many cells this is removing. I do have a support request in our system to, somehow identify obstructions that are blanking, compute how many cells those obstructions occupy, and then give you kind of a subtracted number up here to help you get a sense of how many you've actually removed from the calculation. But for now, just know that you are optimizing the calculation by blanking these out. FDS will see all of these inside of a solid and we'll just ignore those for the gas phase calculation. If you don't blank those out, then everything that you're doing will be calculated in these areas. You'll get temperature and all your scalar transport and energy and momentum and flow and all the stuff that you really don't care about, because only inside the space is what matters to your results and not outside. Now, one other thing, once you do something like this, typically, you would open up all your mesh boundaries, right? And then that would be where your pressure would relieve. And you might have openings or something in here to relieve the pressure. You can't really do that if you've blocked this all out, right? Because you've essentially separated this interior space from any connection to these obstructions. So one thing that you can do is you can use leakage, which we have a tutorial on leakage, which I'll link to in the description for this video. And you can set up some bulk leakage on surfaces and have that leak. And that's one way of relieving the pressures inside of here. Another is to use HVAC vents. And so, if I had somewhere in here, I want it to be like my relief point or something, I could just make a small mesh on the floor here, or a small vent on the floor here. I could convert this to add HVAC nodes. That converts it to HVAC and adds a node in here. And then I'll go ahead and drop another just node out here and make this ambient. Okay, and then I can draw a duct that connects this one to this one. And essentially now I have this little area here becomes like an open vent, because it will draw, based on the differential of pressure between this node and this node, it will either pull fresh air in or relieve and flow air out through this node. It's kind of like an opening on the floor right here. So you'd want to position that wherever you want an opening to be, and then connected up to an ambient endpoint. So that's another tip you can do. And again, go check out the leakage. You can do bulk leakage from all the walls and surfaces through some amount of like leakage area and set all that up. And again, go check that out. That's not the point of this video, but just keep in mind that you're not going to be able to relieve pressures inside of this volume naturally, or like, you know, in a natural or normal way, a physical way, without adding some kind of a leakage capability or functionality to the model, because your open vents won't matter on the mesh boundaries if you block it all out like this. So hopefully that's helpful. If you have any questions, please email support@thunderheadeng.com, and have a good day.